Okay, we're going to be going over triangle congruence by side, 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 and side angle side today. So here we go. The first question that we have right now is just using the diagram to go over some vocabulary. When it says included angle, that means between. So we are finding the angle that is between side AB and side CA, meaning that that is going to be angle A. Similarly, included side between angles A and C, that will be our side AC. Included angle between BC and CA would be our angle C. And then our last one, included side between angle B and C, is side BC. So that's just a little vocabulary for us to figure out what we mean by included, because that is going to be very important here at the end. So yesterday we talked about congruence of shapes, and we were saying that for triangles, they have to be, all the side pairs, all the angle pairs have to be congruent for us to say that they're congruent. What we're going to be doing over the next couple sections is talking about some easier ways to prove that triangles are congruent. We're needing less stuff. So this first one that we have, you can see on the screen, is the side, side, side postulate. It says if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. This is a stronger statement, meaning that we don't have to say anything about the angles. If we know that the three sides are congruent, no matter how we make them, no matter how they're arranged, the two triangles will always be congruent, and we're going to start saying by side, side, side with three letters. So instead of having a theorem that we have to state or a name, we're just going to say side, side, side. Let's take a look at our first proof. So we're going to start with our givens. So bear with me. FG, maybe. Look at how cute she is. So we have FG is congruent to GH. That's given. And we have our next line is that GI bisects FH. That's given. Now, as I have been saying, you read the word bisects even though it's not written very nicely, we're thinking about something. Something is being bisected, so we want to say what that gives us. So it's talking about a side that's being bisected, therefore FH is going to be cut into two congruent segments. And those two segments happen to be FI and HI. So, thinking back to what we're trying to prove that two triangles are congruent, and instead of having to say something about all the sides and all the angles, we are trying to prove by side, 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 use our theorem. So we have two sides already stated. We have one side left. I guess maybe I can put some marks on things to tell you which two we've already said something about. We have this last one right here, and if you remember from yesterday, GI is congruent to GI by the reflexive property. Ugh, this is not writing very well. So, we now can state that triangle FGI is congruent to triangle HGI because we have shown that all three sides are congruent. Okay, moving on to another way we can say that two triangles are congruent without having to say that all six parts are congruent to each other is by side angle side. If two sides and the included angle, please underline, please star that included angle sign or line, that's very important. If one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So we're going to say that triangles are congruent by SAS. We have another way to state congruence of triangles. not saying all the other stuff. Here's the other guy. Mwah. So, looking at these diagrams below, let's see, what other information do we need to prove triangles congruent by SSS and SAS? Looking at this diagram, looks like we almost have SAS. We have a side and we have an angle. We need another side. But you have to make sure that we get the correct side. To prove by SAS, we need the sides. Now, I'm hoping you can pause the video, write down what you think. So pause, write down something, play when you're ready. Hopefully, you're going to get KL. Just kidding. We're not doing KL. That's the wrong one. We need to include the angle. Hopefully you said KJ is congruent to YX. If we had that pair of sides, then we would have side, angle, side, aka the angle is in between the two sides. Do something similar over here on the right. Let's see. We have an angle. So since we have an angle, you're probably going to want to say side, angle, side right now. We know that LB is congruent to itself. Why? Reflexive property. So we have that side. So what do we need? We need NB is congruent to EL to use side, angle, side. We would need this side down here and this side up here to be the sides that would include the angle between them. So take a moment, look at these next couple. I want you to say, yes, we can, no, we can't. If we can, write down the congruent statement. So pause the video, try example 3 on your own. So please pause. Did you pause it? Did you try? Some reason, I don't know if I believe you, but let's keep moving. Hopefully you did. Hopefully you wrote triangle AB. D is congruent to triangle CBD by SAS. Over here, if you realize that they share the same side, we have triangle NPR is congruent to triangle QP. Oh, that's supposed to be a P. R by side, side, side. And for this last one, these two angles right here are congruent because they're vertical angles. However, those are not the included angle. We don't have the included angle. So, can't use SAS for this one. We'd need the angle T and the angle V if we wanted to do that one. And we also don't have the third side, so we can't do side, side, side. Moving on. Example 4. I'm going to start running through these proofs a little quicker. Remember, what we're trying to use is either SSS or SAS. Look what we have given, see what we need. So, I'm going to start writing. T is the midpoint of SP. That's given. What do we know about midpoints? So if T is in the middle of SP, then we know that ST is congruent to PT because midpoints cut things into two congruent segments, very similar to bisecting. So that is a pair of sides. So we got S, one of the S's. 1 and 2 are right angles. That's given to us. Sorry, my handwriting's a bit sloppy. If they're both right angles, then we know that 1 is congruent to 2 because right angles are congruent to each other. So we have this angle and we have these sides. So we have an angle that's making me think I want to be able to prove these triangles are congruent by SAS. That's what I'm thinking. Doesn't mean it has to be that way, but that's what I'm thinking. So that would mean we need another side. We look at this diagram. If the angles have to be included, that means we want this side on the other part of the angle, meaning we need to say that TR is congruent to TR by the reflexive property. Therefore, we can say that triangle STR is congruent to triangle PTR by SAS because we have two sides and the angle between them. Jumping into this next proof real quick. We're almost done. Let's bring up my GIF for that one. We're almost done. Hooray. I guess you can't see all of it now. You can. We're pumped. All right, let's keep going. LN bisects angle OLM. That's given to us. What does bisect make us think? Hopefully you're thinking two congruent somethings. We're dealing with angles, so we're going to say angles. And the angles that are congruent by this bisection are OLN and MLN. So that's an angle. Thinking about what we're using to prove, I'm thinking maybe SAS, but we have this angle up here at the top, so we need to say something about the sides on either side of the angles. So, given to us, LO is congruent to LM. I'm going to draw that up here at the top. So we'll give those markings, and it looks like, again, we are using the shared side, so LN is congruent to LN. Reflexive property, we learned that yesterday, to state that, oh, I guess I should say that's a side. Don't worry about the bad word on the side of that there. OLN, triangle LLN is congruent to triangle MLN by SAS, side, angle, side. Two sides and the included angle. There are our proofs. Last thing, error analysis. Your friends think the triangles below are congruent by SAS. Explain why they are correct or not correct. Two pairs of corresponding sides, I see them. They're marked. Yes, that's true. A pair of congruent angles, I see that too. That is true. Are the congruent angles the included angles between the congruent sides? No. Where would the included angles be? Right there, right there. So I'm not going to write the explanation, but it has something to do with even though we have, oh, this pen isn't working. Even though we have an S and an S and an A, we don't have the included angle. So there are going to be other ways that we prove triangles, but today and this weekend, please do the homework. Please bring that back on Tuesday, ready with questions or just to turn it in. Today we learned about SSS and SAS. Hooray! First video, I'll show you my favorite GIF, maybe of all time. It's just a kid putting ice cream on his face. It is glorious. Have a good weekend if I don't see you. Bye-bye.